Hi there, I'm Hao, and it is just another video of me solving randomly code problem. So today we need to build a prefix tree, a trie. So a prefix tree is the data structure that is used efficiently to store and retrieve keys in the data set or the string. So the use case would be like autocomplete or spell checker. So we need to do three function here: the insert, right, the search, and the start with. And of course we have the constructor, right? Search and start with is pretty similar, right? So let's say we have a header A, right? We can insert like something into a trie. So a trie is basically just a tree, a poly tree, a tree with multiple children, right? Apple, right? And we have uh what is it? Let's see. Let's start with non letter B, A, G, right? So the in the trie it would have a the root node, right, to pointing to in each node we have a children. We have a trie node, right? In each node we have a children, right, where each children is a hash map. So we can implement it using a hash map or an array, right, where each key is a each key would be a character, right? So let's say I have the word app here, right? App, app, this. So it would be here and here. So this would be the second level. This is the third level, right? So no problem is you can just like keep you can think about it in this way. You can just keep iterating to like a letter, right? Of the word, the app, for example, right? And you just like look at this, right? And then the key is the letter, the characters, and the value will be another hash map, right? Which is P, right? So you can search for the word in the trie, like this, right? And you can search for this in O log of, the like the total number of children, the maximum number of children that like a trie node has, right? So if it is a binary tree, it is like O like log of n, right? So this is binary, so log of n, log 2 of n, or we can have log 3 of n for ternary tree, right? And if we have like just lowercase English characters, we'll have like 26, right? So on and so forth. Okay. Um, and then how do we know that we are at the end of the word? Because a lot of words are have redundant, have the similar characters, right, with the same prefix. So we would have like a flag, right, or end of word, which is a boolean to indicate that whether it is the end of the word or not, right? So let's say we all have the apple here, right? So apple is the end of the word. So we can mark it, right? Some special characters. App, right, is also the end of the word here, right? And back, right? We can have like bad, right? Also the end of the word. This is what is it? Bad, right? So we can also build the trie using an array, but it would not be as flexible as using a hash map, because we need to look up the index, right? We need to do all kind of like math operation, like all kind of algebra to figure out the index, right? By looking at the ASCII for each character. So as you can see, we can search for the word, right? We can check whether the word starting with a prefix, right? Like the app or uh, apple, right? We can also insert the word, right? We just keep it. Let's say we are inserting app, right? We can just iterate into each letter, right? If it doesn't exist, we just create a new node, a new try node for it, right? And new is will be put in the children of the current node, right? And we just keep iterating until we reach the end of the word, and then we just set a flag to this flag to true. Okay. All right. So let's code this up. We can have a constructor here. I rewrite this into an ES6 class syntax. So a try we will have a root, right? So which is a try node, and we have to build a class ourselves. So try node. We have a constructor, a post constructor, and we will have a children, which is a hash map, and then a flag and a word. Default is false, right? Okay. So how do we insert? We need to iterate through every single letter of the word. So I less than word of one, I plus plus, okay, and then power equal to word of I, right? And then we need to check whether the characters exist, right, in the try. If it doesn't exist, then we need to create a new try node for it. So try in uh, try dot children node. So we need a pointer to iterating to the try, right? And we can start out the root. So try uh, equal to this dot try. Let's call this something else. Let's call it current current. Okay. So if the char doesn't exist, when we want to create a new node for it, right? So current current uh and then we gave it a new key, right? Which is char equal to a new char node, right? So let's see. Let me try to get my pen here. Second. Okay, so um yes, so if we are so as I said earlier, it is the root, right? This is our try, the root, right? And we're gonna look at the children. Let's say we have like BAD in here, right? And then it is letter A. So it- so this is the children, right? In this level, it is the children. So because like the children hash map, right, doesn't have the char, which is A, letter A, right? Letter A. So we just create a new node for it, right? And then we just keep going, right? Keep going. We update our point pointer, right? And keep going. Okay. So we need to update our current pointer. And so try equal to try dot children, right? So try dot children is a hash map, right? And we need to look into the key, which is the characters, right? The value would be another hash map. So it is a nested hash map data structure, as I said earlier. Like remember, we have like tree level, right? Which is another hash map, right? And this is like another hash map, right? Like that. Okay. So we iterate into each uh, characters deep down into the try, right? And we update our current pointer. This is actually try current, because we did change the name current, right? And then if we get to the end of the word, what are we gonna do? If we got to the end of the word, we want to mark it as end of word, right? So we can check here if the last index of I, right? And we want to do current of children, right? Of char dot end of word equal to true, right? And we can do a helper function for this last index and type in an index, and we return if the index is equal to word dot length minus one. Okay. Yeah, and that's pretty much it, right? Let's say now we don't want we already insert the app, right? We want to insert app Apple. We would iterate into something. We start at the root. We look at the key A. The key A, we have the key A, right? So we because the character exists, right? So we're not gonna do this step, right? We're not gonna create a new node. We just keep update our current pointer to app, right? And then we keep iterating to the next one, which is L, because we don't have the L in our children at this level. So we just add the L and just keep moving, so on and so forth. Okay. Um, so that's pretty much it for insert. So how do we search for a word? So we search for a word by iterating to each character in the word, right? So less than word of length. And then char is equal to word of I, char exists. This is equal to char in current dot children, right? Similar like the last one. So let current equal to default char. Okay. And then if char doesn't exist, what do we want to do? We want to just break out of loop and we can return false at the end, right? And if we are able to get to the end of the word, right? We were able to get to the end of the input word, then we are done, right? The only thing left we have to do is we just have to check to see whether the current characters is the end of the word, right? So we can return current dot current, right? At star dot end of word, right? And we also need to update our pointer, right? Okay. And we need like a helper function for the last index, same as this one. Okay, right? So we keep iterating through uh, our try, right? By updating our current pointer here. And at each level, uh, as soon as we find that the character doesn't exist, we just break, right? I think we are able to get to the end of the input word. Then we're gonna check if that character is the end of the word. And we return. So the start with prefix is pretty similar, right? The only difference is that we're not gonna check for the end of the word, right? Select column equal to this of try, and then we can iterate through the input less than prefix length plus plus, and then the char would be prefix of I, right? And we can do char like this. If we char in parents, parent, the if it doesn't exist, just immediately return false, right? Otherwise, we keep updating our current pointer, right? If we were able to get through all the prefix, then which means that word start, we have a word that start with this prefix, right? So we return true at the end. All right, so let's give it a try. Undefined. So that is insert search. So search undefined. How is it 25? All right, I just figured out that I just have a typo somewhere. All right, so submit. Uh, yeah, and we did pretty well with both pay and time complexity here. So thank you for watching.